So this is lesson 9 on page 471, and class example 1 asks us to use a graphing calculator to sketch this graph. Now we've skipped the graphing calculator stuff for the time being, so I'm going to skip that question. But if you're interested in how to do things on a graphing calculator, you can always email me and I will link you to resources. On the bottom, in class example 2, it's asking us to express this relation given in function notation as an equation in two variables. So what they are asking is that this is currently in function notation, which looks like this. But they are asking us to convert it to equation in two variables, which means like x and y equals something. So that's actually pretty easy because y and f of x are the same thing. So you would just recopy it, but instead of writing f of x, you would just write y. So g of t is this. I guess we can use y is equal to t squared minus 2t plus 35. I guess I don't know what variable they would have used here instead of y. Maybe they would have used g. I don't know. On the last question, express the relation, this relation in function notation. So just going backwards, replacing y with f of x. Just make sure that the variable that you use on the left, x, matches the variable that you're using on the right. And then part C, the graph of the function is defined by y equals f of x, which is saying that y and f of x are the same thing. So it has this equation, and they're asking us just to write it like this. Class example 3 on page 472 is where it gets more interesting. So they've given us a graph of a function f. So it's just a regular graph. Instead of labeling this y, they've labeled it f of x on this axis, but it means the same thing. And it asks us, what is f of 5? In the previous lesson, they always gave you an equation. But right here, they haven't given us an equation. Instead, they've given us a graph. So we just have to look it up. They've given us the value of x, and they just want us to look up y. So we're going to go, well, where is x equal to 5? Right here. And we're going to look up y, which seems to be negative 2. So f of negative 5, or f of 5 is negative 2. F of negative 2, again, just look up on the x-axis. Here's negative 2. Read the graph. Looks like it's at 3. So then this is 3. And f of 4, just make sure you're looking this up on the x-axis. Look it up. Go down to the graph and realize that y is negative 1 here. So these tend to throw students because they always think they need to have an equation. But if they give you a graph, you just have to look it up. So they want us to write the ordered pairs associated with these. You just have to understand that the value that they gave you was x, and you have to write that first. So that's 5. And then y is the value that you looked up. Don't get those mixed up, or you're going to lose a mark for no reason. 4, negative 1. State the values of f if f of x is equal to negative 1. So note the difference in the way that this has been portrayed. In this case, they gave you x, and in this case, they're asking for what x is. That means we are looking up y. So just be careful as to where you're looking this up. So y is negative 1. So if I look up y is negative 1 down here, and I read over to the graph, I'm looking for the x value here, which seems to be 4. And then here, the y value is 3, so I'll look that up on the graph. And then I'll go over, oh, interesting. Actually, there's two ways for me to read this graph when y is equal to 3. So there's a value here at negative 2, and there's another value here at 2. So you have to list them both. In the last example, f of x is equal to 4. So we're going to look up 4 on the y-axis. And again, we have two values of x if you read that down, negative 1 and 1. Then they're asking us, using the notation, to make a statement about point A and B. So really, they're just asking us to write this in function notation. If I look up this point A, it's located at negative 5, comma 1. If we write this in function notation, we would say that f of negative 5 is equal to 1. Similarly, we can look up B. Just make sure you get the coordinates in the correct order. So 6, comma, negative 3. And then you would say that f of 6 is equal to negative 3. Last question. Write the x and y intercepts of the graph using function notation. So first we have to locate the x and y intercepts of the graph. So I have x-intercepts here and here. So I have an x-intercept at negative 6, comma 0, and another one at 3, comma 0. So if I want to write my x-intercepts, I could say that f of negative 6 is 0 and f of 3 is 0. Looking for my y-intercept, which is up here. So the coordinates of that y-intercept are 0, comma 5. So for the y-intercept, I would say that f of 0 is equal to 5. Last part is asking us about domain and range. I have just erased all the scratching so that we can clearly see this. So as always, when we are looking at the domain, we're looking at the bounds of x. What value does it go between? Looks like it goes between negative 6, 6, 7, and 7. So just like any domain, we can write that x goes between negative 6 and 7. Don't worry about this x such that you can include it or you don't have to include it. The range, let's look up here. We're going between negative 4 and 5. So we would write that it runs between negative 4 and 5. And the only difference here is that instead of writing y, they've written f of x. But for your purposes, they mean the same thing. So that's just a quick review of domain and range.